PowerPoint, I'm going to cover arithmetic sequences and series. So first let's define what we mean by an arithmetic sequence. A sequence that increases by a constant amount each time is called an arithmetic sequence. So if we have a look at these three here, we're going to go through each of these sequences and decide which one we think are arithmetic sequences. So in the first one, if we look at the jumps, from 5 to 10, that's a jump of 5. Then from 10 to 20 is a jump of 10. 20 to 40 is a jump of 20. So you can see that the jumps are not all the same. So no, that one is not arithmetic. On the next one, if we look at the jumps, this time it's jumping up by 5 every time. All of the jumps are the same. So yes, this one is an arithmetic sequence. On the bottom one, the jumps are -3 each time. It's going down by 3. It's like saying it's going up by -3. So this one is an arithmetic sequence because all of the jumps are the same. Now in our arithmetic sequences, we are always going to call the jump D. D for difference. The common difference, so the jump between one number to another, we're always going to call D. And then we are going to use the letter A to represent the first term. So when we come on to some generalised questions later on, the letter A will always mean the first term, the first number, and then D will be the common difference. There is a difference between sequences and series. You can have an arithmetic sequence or an arithmetic series. The only difference between a sequence and a series is that in a sequence you have a list of numbers with just commas in between them, and in a series you put plus signs in between them. So when the terms are being added together we call it a series. And that's the only difference really between a sequence and a series. So now we're going to have a look at a general arithmetic series rather than ones with numbers in. Now earlier on we said that we were going to use the letter A to represent the first term. So A is the first term of the series. Now the second term we represent as A plus D, because remember that it's gone up by D. We're using D for the common difference. So the second term will be A add D. Then if we want to find the third term, we need to add D again because we add a D each time as we move from term to term. So the next one is going to be A plus 2D, and then A plus 3D, and A plus 4D, etc. So each term, as we move from term to term, they are increasing by 1D every time. Now if we have a look at the relationship between the term number and how many D's there are, in the first term there's no D, 0D. In the second term there's 1D. In the third term there were 2 D's, and in the fourth term there were 3 D's. And we could carry on with that same relationship. The number of D's is always one less than the term number. So if we were looking for the 10th term, we know that it's going to be A plus 9D, because the number of D's is always one less than the term number that you're on. So if you wanted to write an expression for the nth term, it would look like this: A plus n minus 1D, because the coefficient of D is always one less than the term number that you're on. Now that's a really important formula to memorise. It comes in very helpful in a lot of questions. The nth term is A plus n minus 1D. So here's another example that I've taken from the booklet. We've got an arithmetic series, 5 plus 9 plus 13, etc. And it goes up to 805 and then it stops. It doesn't say plus ... on the end, so that must be the last term. It stops at that point. And the first part of the question is to find the number of terms. In other words, this 805, what term number is that? We know it's not the first term, or the second, or the third, or the fourth, or the fifth. It's quite far along, and we want to try and figure out what that term is. So let's say that that is the nth term. Let's call it Tn for short, term n. Let's say that that one is 805. Remember that we've got a formula for nth term. The nth term is A plus n minus 1 times D. And we know from the the question, the A is 5. That's the first term. We also know that the common difference is 4 because it's going up in 4s each time. So if I fill into this formula what we know, if I put the nth term as 805, A is 5 and then D is 4, I can work out the value of n. I'm going to take the 5 over to the other side and subtract it, and I'm going to expand this bracket on the left hand side. Now I'm going to bring the minus 4 over. 804 equals 4n, so n equals 201. So that number there, 805, must be the 201st number in the series. Question B is quite similar. Which term of the series would be 129? So again, let's call it the nth term. Let's say Tn is 129, and we're trying again to work out what n is. So I'm going to use exactly the same formula as earlier, but this time just bring 129. Let's take the 5 off, expand the bracket, take your 4 over, and then divide by 4. So the 32nd number in the series must be 129. This is another example from the booklet. Given that the third term of an arithmetic series is 20 and the 7th term is 12, find the first term and find the 20th term. Now this is a really popular sort of exam style question. Let's use the information that we're given in the question. The third term is 20. Now we already know what the third term looks like in an arithmetic sequence or series. The third term, term 3, is A plus 2D. Remember that the number of D's is always one less than the term number. And I know that this is 20, so I know that A plus 2D must equal 20. Now I can't solve that at the moment because it's got 2 letters in. So I'm hoping that at this point now you're already thinking about simultaneous equations. We're given another bit of information. We're also told that term 7 is equal to 12. So A plus 60 is equal to 12. So now we've got our 2 equations which we can solve simultaneously. Now you can solve these however you like, but I'm going to write this one on top and then this one underneath. And I'm going to subtract them. When I subtract them, the A's cancel out. 60 take away 2D is 4D. 12 take away 20 is minus 8. Divide by the 4 and I get minus 2. So I now know that the common difference is minus 2. If I substitute that back into one of my equations from earlier, I'll use this one. A plus 2D equals 20. 2 times minus 2 is minus 4. So A must equal 24. So looking back to the questions, in part A, it asked me to find the first term. Well, I've just done that because that's what A is, that's 24. Then part B asked me to find the 20th term, term 20. Well, I know that that is A plus 19D. So that must be 24, add 19 times minus 2. So that's 24 minus 38, which is minus 14. So the next thing that we're going to look at is how to find the sum of an arithmetic series. So for example, if you have a look at this series, you've got 1 plus 2 plus 3 plus 4 plus 5 plus dot dot dot, and then it goes all the way up to 100. So let's say, for example, that we wanted to find out what those numbers added up to. Now obviously you could type it into the calculator, but it would take you absolutely ages to type in 100 numbers, so there must be a quicker way, and that's what we're going to look at next. Now first of all, Carl Friedrich Gauss came up with a clever way of doing this a long time ago, and this is how he worked it out. He said, let's let that sum be called S, and then he wrote it in reverse, and he also called it S. He just wrote it backwards. And what he noticed then was, if you add all the pairs together, each pair adds up to 101. So we added his numbers in pairs. So you can see that those pairs that I'm circling now all add up to 101. And then he was quickly able to work out that there are 100 of those because there are 100 numbers in each list. So there were 100 lots of 101, which is obviously easy to calculate. Then he thought, well, because I've done the series forwards and backwards, and I've added them together, I've worked out what 2s would be. S plus s is 2s. And if we want to get back to what just 1s, the original sum, would be, we'd then have to divide by 2. So we got his answer of 5,050. Now that was for obviously a specific example of a specific series, but we're now going to generalise this and we're going to come up with a formula. So rather than having 1 at the beginning, we're going to call it A, and then the next one it would be A plus D, and then A plus 2D, A plus 3D, etc. So we can generalise using this method and come up with a formula for finding the sum of n terms. So in general, if we say Sn is the sum of the first n terms, we've got our first term, second term, third term, etc. The nth term, let's call that the nth term, is a plus n minus 1d, and we saw that earlier on in the PowerPoint. Then we can reverse the sum, so we can write the same thing but backwards, and then we add the two together. Now we use the same idea that we add them in pairs, like we saw on the previous slide. And when you add each pair together, each pair always makes the same thing. If we look at the first pair, a plus n minus 1d, well, you can clearly see there are two a's and the n minus 1d. And if you add up all the other pairs, you'll find that they turn out to be the same thing. There'll be two a's and there'll be n minus 1 lots of d. So that's what each of the pairs add up to. Then we need to work out how many of those there will be. Well, if in our sum we go as far as the nth term, then there will be n pairs that we're adding together. So that's why on the next line we've got n lots of 2a plus n minus 1d. Now, because we've written the sum forwards and backwards and added them up, we've ended up with 2Sn. So the only last thing to do then would be to divide both sides by 2 to figure out what Sn is. So on the right hand side, that n there has become n over 2. So we've got our formula now for the sum of the first n terms. Now this is given to you in the formula booklet. It's given on the Arithmetic Series section. Sn, sum of the first n terms, is given in two different versions, and we've just proved this second version, half n 2a plus n minus 1d. But even though the formula is given in the formula booklet, you might be asked to prove it, so you need to learn this proof. Now in the formula booklet there's another version of the formula, half n a plus l, which I'm going to talk about on the next slide. So these are the two different formulas in the formula booklet for Sn. It's two different versions. We've proved the one on the right hand side. Now we're going to talk about the one on the left hand side and talk about what that means. Well, this one says half n a plus l. What do you think the L might stand for? And the L is actually the last term. Well, if we are finding the sum of the first n terms, then that L will be the nth term, because the last term will be the nth term. So if I change that L into the nth term, which is a plus n minus 1d, we can see very quickly that that is the same as half n 2a plus n minus 1d. So it's easy to prove that this formula is the same as this one. We just change the L into a plus n minus 1d. or if you're going from this one to this one, you could change one of those a's and the n-1d into L and separate that out from the other a. There's two different formulas for the sum of the first n terms. Okay, so now we've got two different formulas. Here they are again. These are the two different formulas for finding the sum of the first n terms. Which version should you use? Well, it depends completely on what information you're given in the question. If you can easily spot what the d is, the common difference, well then you're probably going to use the top one. But if you don't know d and you know L, the last term, then you might want to use this one. So it totally depends on which letters you know from the question. So let's have a look at an example then of using the formula. Find the sum of the first 30 terms of this series. So I've written out the first 4 terms, but we need to find out what the first 30 terms would add up to. So that there is our n. So we are finding S30. Now we can clearly see from the series that's written out that a is equal to 4, that's the first term. We also know that d is equal to 4 as well, because the common difference, jump from term to term, is also 4. So we know a and d, so I'm going to use this formula. S30 will be half of 30, that's the half n, 2a, so that's 2 4s, plus n minus 1, which is 30 minus 1, times by d. So I'm just going to type that in on the calculator. Turns out to be 1,860. Here's another example. Find the sum of 10 plus 13 plus 16 plus 19 all the way up as far as 58. So this time we know what the last term is. Now we know that a is 10. We can see that d is 3. But I also know that the last term is 58. So in this case I could use either version of the formula. But I'm going to use perhaps this first one. Now, whichever one I use, I need to know what n is, because they both have an n. So the first thing I'm going to need to do on this question is to figure out how many terms there are. That's the n. So let me call this here the nth term. So I'm going to say 58 equals a plus n minus 1d. That's the formula for the nth term. I put in that I know a is 10 and d is 3. I'm going to take the 10 off, so that's 48 equals 3n minus 3. Add the 3 over is 51. So n turns out to be 17. So I've worked n out first. Next I'm going to find the sum of the first n terms. So I'm actually finding S17 now. I can use either version of the Sn formula. I'm going to use the half n a plus l formula this time. I know that n is 17. And then a is 10 and l is 58. So on the calculator, half times 17 times 180 turns out to be 4930. So this example says the fifth term of an arithmetic series is 49. So the first thing I'm going to do is I'm going to write down it in symbols. So the fifth term of an arithmetic series would be a plus 4d, and we know that equals 49. And the 10th term is 99. So a plus 9d is 99. Find the sum of the first 15 terms. So S15 is what we're trying to find. So the first thing I would do is I would solve these as simultaneous equations. If I write the 9 on the top, I'm going to write them that way around just so that I can subtract them. The a's will cancel straight out, That's going to leave 5d equals 50, so d equals 5. And then if I sub d back into one of my equations from earlier, a plus 4d equals 49. So a plus 20 equals 49. So a must equal 29. So now that I've done that, I can find S15 using one of the formulas above. I'm going to use the half n 2a plus n minus 1d because I know that I know a, I know n, and I know d. I don't know l. I don't know the last term of this series of numbers, so I'm going to use that version. So it's a half. Now n for this one is 15 because we're finding the sum of the first 15. 2a would be 2 times 29, which is 58, plus, and then n minus 1 would be 14, because remember n is 15, and then d is 5. So type that in on the calculator, and this come out as 960.